So for today, I'm going to be discussing about web server development and containerization. So okay, so I don't know how many of you have like already backgrounds on background on making web apps, and so but just to reiterate some stuff. So why are we doing this? Why are we like discussing? Why do you want as bioinformatician, as a biologist, to like learn how to make web apps? So first, web apps can make your data more accessible, and then understanding the notions of user experience and human-computer interaction can help scientists gain insights on how to present their data effectively. And also, you're not constrained with the limits of 2D visualizations and can even make stuff interactive. And at the very basic, I think this is mostly if you have like don't have like a programming background. So a basic understanding of how the APIs work and how to use them to interact with various applications is a useful skills when like working with data. So yeah, a brief history of websites. So in the early 90s, around 90s and then early 2000, I guess, websites are pretty much static. So this is how old website looks like. So it's really basically a read-only internet. So and it is focused on that on home pages, and contents are stored in files. So i.e. You have like for example in this one, if you want to go to the tour dates of Britney Spears, you have like a file or HTML file like that has that information, and it's not easily updated. So you have to like update those files every time there is like a new tour date or something. So and also yeah, there is no database, so everything is stored in files. So in around 2006, so rather, and then afterwards, the thing that came after it's the Web 2.0, which is called the read and write internet. So it is dynamic and interactive, and yeah, there's lots of user-generated content. There's already like database are being used, and in fact, the experience is more on the user. The focus is more on the user. That the Time magazine like named you as the person of the year on their like December issue, the December 2006 issue. So okay, so here I'm just listing of some of the what they call this software or tools that are used for web development, and this is not even exhaustive. So there are lots of available things available online on GitHub, on like all other stuff, and it is continuously growing. So it is like it's a really growing field. So for today, we will be focusing on like Flask. So I think some of you have already been using Flask. So just a brief. So I think this was already like introduced on a previous lecture, but so Flask is a lightweight web application framework designed on top of Python. So it is easily customizable, and there are plenty of extensions available. It's really good, but then one downside of it is that the built-in server does not scale, and really it's not suited for like production websites. So what we need is to have like this kind of structure wherein we have like nginx like this nginx and by SGI as something that faces the clients. So this will be a shortcut setup, right? So so there will be like several configurations. So we have to configure our servers, our setup to look to look something like this. So to make our lives easier, we'll actually use Cookiecutters. So Cookiecutters basically these are like templates that are pre-configured with like the best practices. So to install it, you can do this pip3 install --user Cookiecutter, or if you have like Mac, I think there's a brew for it. So you brew install Cookiecutter, and then if you run this which Cookiecutter, this should display the path to Cookiecutter. So that's how you know that it is installed. Okay. So and then we will use the server templates. So we have this server templates on the Mayan lab. So there are lots of Cookiecutters available here. And for our case, we will be using this python-flask-nginx-debian what do you call this template. So I mean, I guess if you wanna try it right now, you can also do it, but you can also like follow the instructions here later on. So this is basically how you do it. So just clone it, and then yeah, you basically just clone it and then go to the cookie cutter branch. So once you got it set up, so you're going to run cookie cutter. So this one. So what happens is that it's going to install, or rather, it's going to like yeah, install, if for the lack of proper term, this template on your current directory. So it will give you like this questionnaires, and then you're just gonna fill this off. So you're like the project name, the version, the description, the tag, and then the license. So and then once you get this answered, it will actually give you like it will give you like a directory with this. So it's already like a pretty setup. So here's your Flask app, and then you have like your Docker files, and then like yeah, and then some of the basic requirements. So to do this, so first you have to go to your to the directory. So for this, we have the web dev summer demo, and then we have this .env example. So we're gonna use this to pass env variables to our program, but we want it to be actually .env and not .env example. So we're just gonna copy this to .env and then modify it to however to whatever environment variables you want to pass on your Flask application. And then to install the requirements, we just do pip install -r requirements.txt, and then you can run it using python run.py. So and then this will be our like once you run python run.py, so you get this, something like this. And then if you go here, so actually to /web dev summer demo, I'll go with that. I'll expound that later. So you have something that looks like this. So this is just the very basic thing that the cookie cutter will like put in the directory. So okay, so now we have this. So now let's get a closer look at app.py. So first we have like this .env. So load.env. This will load the .env file that we use that we copied earlier. So far the .env file should only contain so I'm only just passing it root path. So yeah, root path here. So and then oops. Okay. So and then okay, let me just go that. So this is the root path. So you're basically just getting that from the environment variable, and then flask.send from directory. This is just a function that exposes the static folder, and then the render template here. This is just a function that renders this HTML file. So when you go to this route, so this is the route. So so root path is the root endpoint. So i.e. that's the what do you call this? That's the endpoint, that's the home page, if you will. So that's why it's in here. And then this two here are like, this is how we define a route for our like Flask application. So what is a route? So a route basically this defines the endpoint of our web apps. So for here, so we defined an endpoint that ends with /web dev summer demo, and then /web dev summer demo /static. So and here we also defined a new path, which is find. So there's a root path, the /web dev summer app /find, and then /find /name. So this basically creates a find endpoint. And note that you can have like multiple routes. So you can use this however you like. And then so the first one just have a /find, and then the second one actually passes this variable name to the find function. So you see here, so the default of name is none, but if you use this endpoint, so find /name, it passes it as a parameter. So with this example, So if name, so you can see here, so if you just go to /find, you just get no word entered, and then if you just go to /find/word, you get find word. Okay. So by the way, if you have questions, don't feel free to like interrupt me. Okay. So here's this one way of like sending values to our Flask app. Another way is you can also have this like HTTP requests method. So I think you're familiar with this. So we have like the get and post method. So you can define on the route like what methods it will accept. So for here, I just defined that it will use get, and it will use it wants to get, and then it's either get or post. So and then we can check what method was used to to reach that endpoint using this Flask request that method. So by default, usually if you're like browsing on the web on the browser, it's usually just use this get request, right? So the great thing about this is that you can send like a number of variables or a number of values to your Flask app, and not like limited, and it's not limited and like the /name. So you can send like name, email, or something. So you can add a little bit more. So basically the format here. So this is just a get request from the browser. So you just have this question mark, and then name equals blah, whatever. So that this is what you're sending, find blah. And if you're like adding more variables, you just put like an ampersand. So and email is equal to blah at mssn.com or something. So that's how it is. Okay. So now I'm just using I'm just returning this text. So it's pretty basic. It's ugly. So let's now try adding like HTML. So let's look at index.html. So here is the code for the index. So currently it just renders this template. So index.html, and you can see like this basic HTML file. And actually this is what you call a Jinja template. So often I mentioned earlier that web 1.0 is like file based. So what's the point? So anyway, so one thing that you will notice when you're like doing HTML is sometimes you will have like repetitive blocks. For example, this head thing. So where you have your CSS, the title, or something. It can like appear on like multiple like HTML files. The great thing about so one thing that we can do is that instead is like use that okay, before that, so let's just review like some basic HTML tags. So this determines so HTML basically determines the meaning, and HTML file determines the meaning and structure of a website, and it uses this format, so tags/tags to define an HTML element. So here are just like some the summary of like the tags, and then like some description. So okay, so as I was saying, so here's the templating with Jinja. So templates allow us to automatically generate this HTML. So and dynamically. So what it does is that we can like pass variables in it, and then it will like create, or as you can see earlier, there's this render template something. It will render those HTML files based on like what variable you sent over yeah, to the Jinja template. So templates contains variables that are that's what I said. And then the good thing also about this is templates are inheritable, so you don't have to like repeatedly put like the CSS file or something. You don't have to repeatedly put it on each HTML file. So you can definitely like inherit things. So how does this work? So let's see this basic template. So I created this base.html. So basically this will be the base. So it will be like inherited by all of the other HTML files that I will, or rather all of the templates that I'll be creating afterwards. So you can see here, I also added for like so that our website will be pretty, like a CSS framework. So I use like Materialize. So there are other there are other CSS framework available. So we have Bootstrap, we have Foundation. So I'm not going to discuss this, but you can. But it has like a good documentation, and you can and the websites of these frameworks have like good examples if you wanna look at them. So and then here are the blocks. So what happens here is that you define these blocks, and then once like a template inherits it, this block will be replaced with whatever content you you put on the template. So I will show you how this works later. And then lastly, this is a navigate. So this just create a nav bar with like home and find. And then this is URL4. So this is just basically the URL that you defined on each of the routes rather. So okay. So all right. So now here is the example. So we modified index.html. So here so first we inherit base.html, so we extend it, and then here so we replace block.title with like homepage. So that should be in it, and then the block content with like my summer app and then web dev summer demo. So and once we go to that endpoint, so /web dev summer demo, so we have like this this basic look. Okay. So and then now let's go with find. So for find, I just fix it. So I just put this instead of like returning a text. So I just made it render this find.html, and then I'm passing this variable name. So name equals name. So in here, and this is our template for the find.html. So again, so the title will just be find, and then see here we can what good thing with Jinja is that you can put like conditionals, you can put loops in it, so that you can you don't really have to so that it's easier rather to like rather you can like programmatically control whatever the content in Jinja in your template is. So here I just made like a statement. So if there's a name, if it's not none, so I'll just display searching whatever that name is. Otherwise, I'll create like this form. So this form wherein there's an input, the text input, and then there's a button. So let's see how we did that. Okay, so just conditionals with Jinja. Then yeah, so clicking. So in here, so clicking the button or submitting the form sends whatever you type on that text input to the server. So here, so you can see what happens. So if you just do /find, you'll just get this form. And if you type summer and then and click submit, it will go to this URL. So finds question mark name equals summer, and then it'll display the searching summer thing. So yeah, great. So okay, now let's add some functionality. So okay, so we're basically we're done with like creating like this template. So we want it to work to do something interesting. So just an easy example, I guess. So suppose you want to /find to search an ontology, say like tissue ontology like Uberon, and returns its preferred name plus some other metadata. So we have like two options. First, we can utilize APIs like the OLS. So this is just an ontology lookup service. So I think some of you are already doing this. So like you're working with APIs, so you just do like a request or something. And then another option is like to download the Uberon data and put it in our database. Now, since I want to demonstrate how to like create a database, so for the purpose of demonstration, we'll do the latter. So first, we need to set up a database. So there are several options that we have. So we have like a relational database, which this type of database organizes data as a set of tables. So we have like MySQL, Postgres, and then SQLite. And then there's also like a NoSQL. So for this, we'll be using SQLite. So this is serverless. We don't really need to set up anything. So, yeah, we don't have to install anything, or it's in there, and it's actually file based, so it's very easy. So, okay. So this is just basically an example of a relational database. So basically, it's a set of tables, and then each of this table could have like have relationship. For example, a customer can have like a subscription to a streaming site. So then in this table, you see which streaming site a customer is like subscribed to. Okay, so all right. So next, we go with SQLAlchemy. So SQLAlchemy basically this acts as a middleman between our Flask code and the database. So we use SQLAlchemy. So using SQLAlchemy, we can actually construct database queries in a very Pythonic way. So you'll have none of those like select star where something something is equal to something something. So the queries will be like very Pythonic. So it's very easy. And then we're actually using Flask as SQLAlchemy, which is a Flask extension that extends SQLAlchemy. So to install it, so we just have to like edit our requirements.txt. So with like Flask SQLAlchemy equal 2.4.1. Actually, you can remove equal if you want like the latest version of Flask SQLAlchemy. And then you can just rerun this pip install -r requirements.txt. Okay, so once you got this set up, we can now configure our database connection. So just import this and then do this app.config SQLAlchemy database URI is equal to SQLite something something. I guess this should be not enriched.db, but you can be creative with like maybe this should be ontology.db instead of enriched.db, so it's descriptive with our database. So yeah. So once we got this running, so we can now create a model. So models in the context of SQLAlchemy, like our Python classes. So this defines how our database will look like. So for example, we have like the Uber CSV data downloaded from this website. So it has like various fields, but for our purposes, we just use this 5 fields. So we have the class ID, then the preferred label, and then the list of synonyms separated by a type, and then a definition, and then this obsolete tag. So it tells if that term is obsolete or not. So now, so we can create like a simple like table. So we have like a tissue table and then a synonym table. In a tissue table, it's just basically an ID, the class ID from this one, and then the label, which is the preferred label, and then the definition. And then we have like a synonym table, wherein a synonym table has an ID, a tissue ID, which is a foreign key, this is a many-to-one relationship with right, yeah, it's many-to-one relationship with the tissue table, and then the name of the synonym itself. So here is our model in Python in model.py. So here you can see we just create this class. So we just have this variables. We define what we expect of this variable. So for example, the UID, we expect it to be a string. So since this is a UID string, which of length 35, and then we set it as a primary key. And then class ID, so we set this as a string. And then, of course, it doesn't make sense to have, so since this is an ID, this should be unique. Next is label. So it's also a string. And then nullable equals false, i.e., of course, preferred label, it doesn't make sense if it is like, if it doesn't have any values, right? And then definition, by default, since there are like non-values, we just want it to be like none. It has to be an empty string rather. And then this one, this one defines a relationship with the synonym table. So we will be using that when we're like defining the foreign key here. So as you can see here, So for the synonym table, we have just the UUID, the tissue, and then here we define like the foreign key, so DB foreign key, so tissue.uuid, and then of course this should not be nullable. And then the synonym, which is just a string. So, and then this is just the init. So this is how we like initialize functions in the functions rather classes on Python. So we just assign the values to the values to this variables. So okay, so and then we can now initialize the database. So first we import DB on our here. Well, this is actually just from app. So import DB, and then if you want to drop the tables, so we do this db.drop all. And then if you want to create these models, the tables using this model, so we do this db.create all. Okay, so once we have that, we now want to fill in our database. So this is just basic. So what I did here is just imported the Uber CSV, and then I just filtered those that are not obsolete, and then fix those NaN values with empty string. And then once I got here, so I just looped over the data frame, and then this is how I save, or rather I like push the entries to the database. So here what I did is first I initialize a tissue object named tissue, small tissue. So with the class ID, label, and definition, and then I do this db.session.add tissue. So this basically adds it to the database, and then for synonym, well, yeah, for synonyms, so I just loop over the synonyms in here. So I did a split here, and then just initialize a synonym object, and then do also db.session.add. And then afterwards, I do this db.session.commit. So this basically saves it to the database. And then this is an try catch exception. So what we want is that if there's any error, we don't want those event news entry to be saved in the database. So we want to do this db.session.rollback if ever we encounter like errors during this operations. Okay, so now we have like a working database. So we can now do like various queries. So here you can see how easy it is to like do like a query on using SQLAlchemy. So you don't have, as I said earlier, you don't have to create those SQL statements. So what you can do is it's very Pythonic. So in this example, so we're just querying the tissue, and then we're actually joining it with the synonym table. So, and we join it on this foreign key. So the tissue ID should be equal to the tissue ID, and then we filter it out. So we want the name that we're sending. So the name that we're sending to either be a synonym or to be the label of the tissue, and then we return that all. So preferably if you're working with like if you're expecting like large result, you don't want this .all to be .all. There's SQLAlchemy has this .paginate, so it will like paginate the results. So but since this is like really small, it will just return like a small number of terms. So I just did .all here. So and then we have that find.html. So we pass the name, and then we pass this tissues variable, tissues, the result, which is the tissues. So and then I just modified find.html. So you can see here. So I added this part, so which creates a table. So this results for like whatever you're searching, and then this creates a table, and then see here, this is how I define like a loop. So instead of like doing like a multiple like plenty of TRs, so I just created one big loop, and then I loop over the tissues, and then just fill in the cells with whatever with the label, the class ID, and then the definition. So for example, so here I search for blood. Actually, I can actually demo it. So What's that? Localhost TP80 web. Okay, so this is our summer up. So I'm very good at descriptions, I guess. So when you do find, so there's the submit. So if you like search, yeah, skin. So if you submit, so you just get this labels, class ID, description. So it's very basic, but you can play with it. You can like make like your more creative or more complex web apps using these things that I have been like introducing to you. So okay, so now we must now prepare like our web apps for deployment. So the problem with here is that a web app built on Mac may not work on different machines. So on machines running on Linux, Windows, or even a different version of Mac. Also, you may be using like various dependencies that may no longer exist or not actually compatible with the system. So this is like a problem since way back. So the solution, one of the solution that was placed is Docker. So what is Docker? So you may be familiar with this already. So Docker basically this packages a web app or like an application basically in a container. So container is basically a sandbox, or it contains everything it needs: libraries, packages, the libraries, packages, etc. And this allows us to ship our app to other machine with ease. So because it's basically like a self-contained environment or like a self-contained container. That allows us to ship our apps to to other machines or to our servers, if you will. So here's a Dockerfile. The Dockerfile basically is a text document that defines the commands that will be used or that will be executed to assemble the image. So you can see here. So this is basically all the commands that will be run to build our like image. Actually, I edited this. I edited this, so I added like some other stuff. So just to where is it? Just to like do this like database creation. So I just added it in the Dockerfile. But yeah, so the cookie cutter earlier. So this was created by the cookie cutter we used earlier. And if you have like other dependencies, so if you're like using like other like database like Postgres, maybe MySQL, or you have like other requirements that you need, so you just need to put it on this deps.txt file, and it will actually like install this dependencies on these dependencies. Also for like Python packages, you put it on requirements.txt. Okay, so now we have this Dockerfile, so we can now build our image. So here is how we do it. So docker build -t and then the name of the image. So for example, docker build -t and then nyanlab/web dev summer demo, and then this is the version which is the current directory. And then if you want to run it, so you just do this docker run -p, which is the mapping of of the port, the Docker port to the outside port, and then like the name of the tag of the image. So and then to push it, so if you want to push Docker image, you can push it on Docker Hub. You need an account here. And this is basically a repository for pre-built Docker images. And you can pull images from it using Docker pull, and then push your own images using Docker push. So here, so you can Docker push and then the name of the whatever image. And then this one, the first, the name before the slash is basically the place where you wanna put it. So usually, if you have like a username, for example, like me, and my account is John Erol, so I just put John Erol /web dev summer demo colon whatever tag it is, whatever version it is. So you can if you have your own Docker Hub account, so you can definitely push your images using that kind of command. So last, so we have like a Docker Compose. So Docker Compose, so if you have like a multiple Docker image or Docker containers, so or Docker files, yeah. So Docker Compose allows us to define and run multiple Docker applications. So here, this is just one application, which is app. But if you have like a MySQL one, like a database one, and then I don't know, some other like applications that are like interacting with each other. So Docker Compose is a good way. It's a good way. Yeah, it's a good way of like setting those Docker applications up. So the configurations are written in this docker.compose.yaml, and here, as I've said, we define one application and it is named app. And we can set the ports, environmental variables, the volumes using this Docker Compose app. So you can play with it. And then a cheat sheet, so it's easy to do this. So since we already defined like the name of the image that we want, the name of the image, so we don't have to like do this long commands. Well, long commands here. So we just building things is as simple as Docker Compose build, and then running it is Docker Compose up. And then if you don't want it to be verbose, so if you do Docker Compose up, you'll have something that looks like this. So it has this logs. But if you do but if you do Docker Compose -d, it's not stopping. If you do Docker Compose up -d, it will return to your command line. So it will not display anything. So, and then to stop application, you can do Docker Compose down, and then to push it to Docker Hub. So we have Docker Compose push. So, and then once you got it in there, you can basically just do a Docker Compose pull. So if you go to your servers and you want to deploy it, you can go to your server and then just do a Docker Compose pull, and then it will like pull your Docker container on the server, and then it will basically, the server will basically host that container, and then you can like access it from there. And I think someone will be discussing about cloud computing, and then we'll go in more details on doing this like in a future lecture. So I guess that's it. So, and if you wanna get the demo, so this is I pushed the demo on this Mayan Lab /webdev demo, so you can clone this clone the basic website that I created. So yeah, and do you have any questions?